two projects. In this video, we are going to explain about the project, which is use of deep learning for continuous prediction of mortality for all admissions in intensive care units. Coming to the introduction, patients in the intensive care unit, which is ICU, often have life-threatening conditions or they are at risk of developing them during their ICU stay, emphasizing the critical need for early recognition of changes in illness severity to aid in their recovery and stabilization. In hospital mortality, it is a pivotal outcome in the ICU, with approximately 11% of deaths resulting from the failure to identify patients at risk of deterioration. Accurate mortality prediction models are essential for identifying high-risk individuals and optimizing ICU resource allocation. Traditionally, rule-based severity scoring systems were employed, but the advent of artificial intelligence and machine learning techniques has led to the development of more dynamic models. However, there has been a long-standing desire for continuously updating patient assessment systems. This project aims to develop a predictive model for continuously predicting all-cause mortality in ICU settings using an RNN-based approach. It is built upon the work of previous researchers with enhancements such as dynamic window generation for sequential model input, label balance improvement through resampling, and comprehensive model evaluation methods to ensure its performance and reliability. Coming to the objective of this project is to develop a predictive model that can continuously assess the severity of patients in the intensive care unit, which is ICU, throughout their hospital stay and provide real-time predictions of their risk of death. The project aims to enhance hospital performance by allowing physicians to focus on high-risk patients and anticipate potential complications, ultimately reducing ICU mortality. The proposed model is compared with other machine learning algorithms including logistic regression, random forest, and XGBoost to demonstrate its superior performance in the terms of accuracy, F1 score, precision, and recall. To implement this project, we need software and hardware requirements. Coming to the software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies are of HTML, CSS, JavaScript, and Bootstrap 4. Coming to the hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8GB and above, and hard disk of 25GB and above. To implement this project, we have designed various steps in the flow of work. The first step is importing the packages. In this step, essential libraries and packages are imported. These include Python libraries like Pandas for data manipulation, NumPy for numerical operation, Seaborn and Matplotlib for data visualization, scikit-learn for machine learning, and TensorFlow for deep learning. Coming to the next step, which is exploring the dataset, the project begins with the exploration of the dataset, particularly focusing on the mortality data. It typically involves the examination of the dataset structure, content, and statistical characteristics. This is essential to understand the data before processing and modeling. Coming to the next step, which is data processing, the data is converted into a Pandas data frame, making it easier to manipulate and analyze. Data cleaning processes are applied to handle missing values, outliers, or other data quality issues. Coming to the next step, which is visualization using Seaborn and Matplotlib. Data visualization is performed to gain insights and a visual representation of the data. Seaborn and Matplotlib are used to create graphs, charts, and plots for better understanding. The next step is label encoder using label encoding. The categorical data in the dataset is encoded into numerical values using label encoder to prepare it for machine learning algorithms that require numerical input. The next step is smooth sampling the dataset. Smooth means synthetic minority oversampling technique. It is used to address class imbalance by oversampling the minority class in the dataset. This helps to create a more balanced dataset for model training. Coming to the next step, which is splitting the data into train and test. The dataset is divided into training and testing sets to evaluate model's performance. This helps to ensure that the model is not overfitting the data. The next step is building the model. Multiple machine learning and deep learning models are constructed for the task of predicting mortality. The next step is training and building the model. The models are trained on the training dataset and assessed for the predictive capabilities. Model performance is evaluated using the metrics like accuracy, F1 score, precision, and recall. As an extension, We have applied an ensemble method combining the predictions of multiple individual models to produce a more robust and accurate final prediction, and we built the front end using the Flask framework for user testing with the user authentication. Coming to the next step, which is Flask framework with SQLite for sign up and sign in. Flask, a web application framework, is used to create the front end of the project. It provides a user-friendly interface for interaction. The Flask framework is extended to incorporate user authentication using an SQLite database. User can sign up and sign in to access the prediction functionality. Coming to the next step, which is user gives input as feature values. User provide input in the form of feature values relevant to the ICU patients. These inputs are collected and processed for prediction. Coming to the next step, which is the given input is pre-processed for prediction. The user input is pre-processed to ensure that it is in the format suitable for trained model. This may involve data validation and transformation. Coming to the next step, which is trained model is used for prediction. The pre-processed input is then used as an input to the trained machine learning or deep learning model for mortality prediction. The last step is final outcome is displayed through frontend. The prediction outcome, which is the estimated risk of mortality, is displayed to the user through the Flask frontend, allowing them to make informed decisions based on model's assessment. Algorithms used in this project are logistic regression. It is a fundamental statistical model for binary classification, and it has been employed in this project as a baseline model. Its role is to model the probability of binary outcomes like mortality. The simplicity and interpretability of logistic regression makes it valuable for understanding the impact of individual features on mortality in ICU patients, providing a foundation for more complex models used in the project. The next algorithm used is random forest. The project harnesses random forest as an ensemble learning technique due to its capability to handle complex, high-dimensional data and its ability to provide robust predictions. By combining multiple decision trees, random forest offers improved accuracy and reduced overfitting. This is particularly valuable in the context of ICU mortality prediction, where there may be numerous variables and complex relationships to consider. The next algorithm is XGBoost. It is an optimized gradient boosting algorithm. It is employed in this project for its efficiency and high performance. In the context of mortality prediction, it excels at handling large datasets and captures intricate relationship between variables. This makes XGBoost a powerful tool for achieving state-of-the-art results and delivering accurate predictions for ICU patterns. The next algorithm is RNN. It is designed for sequential data. It plays a crucial role in capturing the temporal aspect of ICU patient data. By analyzing sequential observations, they continuously assess a patient's condition, enabling real-time mortality prediction. RNNs are ideal for understanding how patient status evolves over time, a key factor in ICU care and decision-making. The next algorithm is LSTM with autoencoder. It is a sophisticated deep learning combination. It is used to capture complex temporal dependencies and extract meaningful features from ICU patient data. LSTM addresses the vanishing gradient problem and that can learn long-term dependencies in sequential data. The integration of autoencoder enhances the model's ability to comprehend intricate patterns within the data, enabling more accurate and context-aware mortality predictions in the ICU. As an extension, we applied an ensemble method combining the predictions of multiple individual models to produce a more robust and accurate for final prediction. Here we have comparison graphs of the project. The first comparison graph is accuracy score. Accuracy is the proportion of correct predictions in a classification task measuring the overall correctness of a model's prediction. Here in the graph we can see that x-axis represents accuracy score of each algorithm and y-axis represents algorithm names. And this is the precision score graph. Precision is the ratio of true positive predictions to the total positive predictions, representing the model's ability to correctly identify relevant instances while minimizing false positives. Here we can see that x-axis represents precision score of each algorithm and y-axis represents algorithm names. And here we have recall score graph. Recall is also known as sensitivity or true positive rate. It is the ratio of true positives to the total actual positives, measuring a model's ability to capture all relevant instances without missing any. Here in this graph we can see that x-axis represents recall score of each algorithm and y-axis represents algorithm names. Here we have F1 score graph. F1 score is the harmonic mean of precision and recall, offering a balanced measure that considers both false positives and false negatives, making it suitable for imbalanced datasets. In this graph, we can see that on x-axis it represents F1 score of each algorithm and y-axis represents algorithm names. For execution of the project, first we need to open the code folder which contains source code files. This is the code folder of the project. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. And here we have templates folder. This folder contains all HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. It contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database and generating dynamic content that to be rendered in HTML templates. And here we have model file. It contains algorithm information which will be loaded into project code during runtime. And here we have notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it popular choice for the data science. And here we have signup file. This file is the database file used to store the user information. Now we need to copy the path from the code folder of the address bar. So I'm copying this path. Now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. Here we can see that current directory is changed to the code folders directory. Here we need to type the command which is python space app.py and click on enter. This will compile app.py file. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address which is the localhost and the port. This is the localhost and this is the port. Now we need to copy this local link provided by the framework and paste it in any browser. I'm copying it. I prefer Google Chrome, so I'll paste it in that. So here we need to paste the link and then click on enter. Here we can see that the page of the project is displayed in the browser, and this web page is built by using the Flask framework. Here we can see a link which is sign up link. First we need to click on that. So I am clicking on it. Here we need to enter all the sign up details if we are signing up newly. I have already signed up and I have an account in it, so I'll directly click on sign in. Here we need to provide the username and the password. So I'm giving my username and the password and then click on sign in. We can see that we are redirected to home page where we need to enter all these parameters and then click on predict. Now we will understand all these parameters. Here we have the gender. Here we have deficiency anemias. Deficiency anemias refers to the parameter which represent anemia caused by nutritional deficiencies. It can affect patient overall health and recovery. And here we have the depression. Here we have COPD. COPD refers to chronic obstructive pulmonary disease. It is a chronic lung condition that can impact patients' respiratory function and overall health. Here we have the heart rate and here we have the temperature. Coming to the urine output. Urine output is used to assess kidney function and fluid balances. Changes in urine output can be a sign of kidney or fluid related issues. Here we have leukocyte. Leukocyte count represents the number of white blood cells in the blood. Abnormal counts can indicate infection or inflammation. And here we have lymphocyte. Lymphocytes are type of white blood cell changes in the lymphocyte count can be associated with various health conditions including infections and immune system disorders. Here we have the PT, which refers to prothrombin time. It is a blood test that measures how long it takes to blood clot. Abnormal PT values can indicate bleeding disorders or clotting problems. And here we have urea nitrogen. BUN is a blood test used to assess kidney function. Elevated urea nitrogen levels may suggest kidney or metabolic issues. And here we have blood sodium. Blood sodium levels helps in associating assessing electrolyte balance. Imbalances can affect nerve and muscle function. And here we have anion gap. It is a calculation used to assess acid-base balance in the body. It can indicate metabolic acidosis or alkalosis. And here we have pH. pH means acidic base pH. pH measures the acidity or alkalinity of blood. Abnormal pH values can indicate acid-base imbalances in the body. And here we have bicarbonate. Bicarbonate levels are related to acid-base balance in the body. Abnormal levels can suggest metabolic imbalances. And here we have the lactic acid. Lactic acid levels are indicative of body's metabolic state. Elevated levels can be sign of tissue hypoxia and metabolic issues. And here we have PCO2, which is partial pressure of carbon dioxide. It is a measure of carbon dioxide in the blood and it is important for assessing respiratory function. Abnormal PCO2 levels can indicate respiratory issues. Now we will enter all these parameters. So the gender will be 2, deficiency anemias will be 1, which means he has anemia, and the depression is 0, which means he is not depressed, and the COPD value is 0, heart rate is 83.69231, and the temperature is 36.9222, and the urine output is 1495, and the leukocyte is 10.74286, and the lymphocyte is 4.9, PT value is 12.55, urea nitrogen is 54.7, blood sodium value is 132.8182, and anion gap is 14.5, pH value is 7.368333, and the bicarbonate value is 28.8, and the lactic acid value is 0.7, and the PCO2 value is 54.91667. Now we need to click on predict. Based on the given parameters, it is predicted that the patient will be dead after departure from ICU. Now we will enter other patient parameters. So here we have entered other patients' parameters and now we need to click on predict. Based on the given parameters, it is predicted that the patient will be alive after departure from the ICU. In this way, if we give the parameters of the patient, which means details of the patient, the system will predict whether the person will be alive or dead after the departure from ICU. Now we will sign out. Conclusion of the project. The project successfully developed and implemented a predictive model for continuous mortality assessment in the intensive care unit. This module provides real-time risk predictions which can significantly improve patient care and outcomes. The project explored a variety of machine learning techniques including logistic regression, random forest, XGBoost, and deep learning models like RNN and LSTM. The diversity of models ensured a comprehensive approach to mortality prediction. The use of smooth sampling helped mitigating the issue of class imbalance, making the model more robust and capable of handling data with varying levels of mortality. By incorporating the Flask framework, the project offers an intuitive and accessible user interface. This allows healthcare professionals to easily input patient data and receive real-time mortality risk assessments. The project outcome empowers healthcare providers to make timely, data-driven decisions for patient care in the ICU. This can potentially lead to early interventions, improve resource allocations, and better patient outcomes, ultimately contributing to the enhancement of the healthcare services.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.